Hello everyone. In this video, we will be starting a new series for Java concurrency. In one of my videos on YouTube, I got a comment that if sir, can you please start a series on Java concurrency? And hence, this is the first video in that series. In this video, I plan to cover some of the most frequently asked interview questions related to multi-threading and concurrency in general related to Java language. Part second will also be concerned with further interview questions. And in subsequent videos, we will be seeing some of the coding examples and other related topics. Before getting started, if you have not watched the distributed concurrency control videos, there have been two parts, part one and part two. And if you have not watched those parts, then I will highly recommend watching those first because in that I have explained what a critical section is, the difference between a process and thread, and other related things, which will be useful in this video. Although this is not a hard prerequisite, but I will still recommend watching the at least the first part where I explained the basics. So coming to the first question, what is the difference between multitasking and multi-threading? So multi is there in both the words. Multi means many. The only difference is tasking and threading. So multitask. In general, when you say that this person can do multitask, that means you are referring to different tasks. For example, they can juggle the balls while they can sing, or someone can listen to the songs while studying. This is multitasking. So they are handling different tasks. Let's say, on the contrary, some person is typing, and let's say while typing itself, they start highlighting the text itself. So they are in the same task, right? They, for example, they have Notepad or Apple Notes. They are doing the same task in the same program. Then you do not say that they are multitasking, although they are doing different things, typing as well as highlighting the text. But since they are using the same program, you don't say that they are multitasking. So when we say multitasking, it means running multiple programs, also known as processes, at the same time. For example, Chrome, Spotify, VS Code, they are running at the same time in your laptop. Then we say that your laptop is basically handling multiple tasks at the same time. Multi-threading, on the other side, is running multiple threads, as the name also suggests, within a single program. Say multiple tabs in Chrome, each handled by a thread. So what does this mean? This means that, for example, you are writing an email, and while writing the email itself, the email starts highlighting some of the words that these words are misspelled. So that means there are at least two threads running. One thread is writing to the screen whatever you are typing. The other thread is doing the spell check behind the scenes. Similarly, each tab in Chrome is handled by a single thread. So let's say you have 100 tabs open in your Chrome browser. It will mean that there are 100 threads, at least 100 threads running in the Chrome. If we talk about Java, then multitasking is done using multiple processes. And process is nothing but a program which is loaded in memory for execution purpose. This we discussed as part of the distributed concurrency control part 1. While multi-threading is done using thread class or the runnable interface. So multitasking is basically running multiple processes, and this is generally not much of a use in an interview. But multi-threading is quite commonly asked, and this is usually implemented using either thread class or using runnable interface. So let's first understand what a thread is and why should we have threads. So this is the second question, why we should have threads. So thread is nothing but a lightweight process within a process. So thread cannot exist outside a process. A process can have multiple threads. So if this is a process, then it can have multiple threads. And is the smallest unit of execution. That means if some execution or some task is there and it is being handled by a thread, then we say that this task cannot be broken down into multiple components and be handled by multiple threads. All Java programs have at least one thread. Whenever you write a Java program, the entry point to that is the main method. And this main method is actually invoked by a main thread. So each Java program will have at least one thread, which is the main thread, which invokes the main method, called the main thread, created by the JVM, Java Virtual Machine, to invoke the main method. This we already discussed here. All other threads are children of this main thread because this main thread invoked the main method. And since main method starts executing, then only you will create other threads. So in a sense, all other threads are actually the children of this main thread. So we discussed what a thread is. Now, why do we need threads? We have processes, we can load the programs and run it in memory. What's the issue with that? The first issue is that processes are heavyweight. You have to load, for example, a GTA Vice City. Consider this. This is easily, I think, 2-3 GB, or if not more. Now, to run this, the loading itself is quite hectic, right? You click on the program, the icon in the laptop, and then it starts loading. There is a preloader, then it boots up. Then after 10-15 seconds, the game starts. So they are very heavyweight. When you load a program to make it a process, the loading itself is heavyweight. Creating new processes means loading the entire program from disk to RAM, which is much slower. This we already discussed with the example of GPU. Also, inter-process communication is very slow since each process has its own address space. Now, this address space requires a little bit understanding of embedded systems, but this is not of much use from an interview perspective. So just understand that inter-process communication is two processes doing the communication. So P1 is communicating with P2 and vice versa. This is very much slower because each process maintains its own address space. So let's say if P1 says that, hey P2, can you access this address space? Let's say A. This A is not accessible by P2 because P2 does not have access to P1's address space. So generally some shared memory is used where P1 writes, which P2 can read, and P2 writes, which P1 can read. But this shared memory is basically a critical section. Critical section also we discussed in part 1. So critical section, then we need some kind of synchronization. Synchronization, don't worry, we will discuss soon in one of the upcoming questions. Or we generally write P1 writes to kernel buffer. And this kernel buffer then passes the information to P2. So this is much slower. Moreover, context switching for processes is also heavy. So context switch we also discussed as part 1 of distributed concurrency control. So context switching for processes is also very heavy. On the contrary, threads of a process share code, data, and files. So you see, if it is a single thread process or a multi-thread process, the code, the data, and the files are being shared across all the 3 threads. Each thread has its own stack and registers. So if someone asks you what is being shared by threads of a process, then you say that threads of a same process share the code, data, and files, but each thread maintains its own stack and registers. Stack and registers are separate for each thread to track the execution status and to resume the task from where the thread left when the context switch happened. So each thread stores its own local variables in its own. So till now we discussed that threads are actually very lightweight processes, whereas processes are heavyweight. So does it mean that if we increase the number of threads in a process, will the performance of the process always increase? Think about this. The answer to that is no. So this is the third question. In all cases, does increasing the number of threads increase performance? Let's read. Every process tries to have a multiple threads to improve performance and reduce task completion time. Increasing the number of threads does not always improve performance. So the answer to this question is no. But why? So if threads exit available CPU cores, laptop, there are 8 CPU cores available, but the number of threads which you are running is 10. So 10 is obviously much greater than 8. That means at that given moment of time, even if one thread runs on a given CPU core, 8 cores will be busy, but 2 threads will be idle because they don't have any more CPU core. So due to the lack of resources, the extra number of threads, which in this case is 8 minus 2, that means 2 threads will be waiting. So excessive context switching reduces performance. Because in this case, 2 threads are idle. So let's say after some time, one CPU core decides that, CPU core 1, let's say decides that, okay, now it is the time to run the one of these threads, the idle threads. It will start executing this thread. So at least one more thread which was executing till now should go to the idle state. So this will lead to excessive context switching, which will reduce the performance eventually. So the first rule of thumb is always keep the number of threads less than equal to the number of CPU cores, at least for the CPU bound tasks. For example, if you are waiting for something from the user, then it is related to IO bound, not CPU bound. So if it is IO bound, then it is fine because it is not related directly to the CPU cores count. But if it is CPU bound task, for example, doing some calculations, let's say you are adding or doing some arithmetic calculation, then it is more prudent to keep the number of threads less than equal to the CPU core count. Moreover, more threads need more memory. If the memory is insufficient, it can cause thrashing. So this is called thrashing, which basically means degradation in performance. So if someone asks you what is thrashing, you might have heard this in your operating system classes as well. But thrashing basically means that as we increase the number of threads, as the degree of multiprogramming increases, the CPU utilization increases. It reaches a peak which we call as optimal. After that, if you keep increasing the number of threads, then CPU utilization decreases. So what we want to achieve is this point, the optimal, at which the CPU utilization is the maximum. Use thread pools, executor service class, to reuse existing threads instead of creating too many threads manually. Java provides a class called ExecutorService, which can be used to reuse the existing threads. We don't need to create many threads again and again manually. Multiple threads may help in scenarios like downloading multiple files in parallel, which is an IO bound task. By parallelizing downloads, let's say a download file is divided into 3 chunks, chunk 1, chunk 2, and chunk 3. Then each thread can download it, and then operating system can stitch it together to create the entire file again, and thus improvement in the speed. The fourth question is, what are the properties of a Java thread? Java thread has 4 properties. The first one is the thread ID, which uniquely identifies a thread. The second is the name of the thread. The third one is the priority of the thread, and the fourth one is the thread group. Now thread group is kind of a legacy feature now. In lieu of the executor service, this feature is now legacy. But if someone asks you, then you have to mention 4 things: thread ID, name, priority, and thread group. For example, if I create a simple class and then do a thread.current thread, this will be obviously main thread because I am not creating any thread, any extra thread in this class. And we know from above that there is at least one thread called main thread. So that means it should print main. So what it prints is thread, which is the class name, then number 1, which is the ID, the thread ID, then the main, which is the name of the thread, then the priority, then the main, which is the thread group. The thread group is a legacy feature in Java, but it was introduced so that it provides a way to handle multiple threads together. Let's say you create 5 threads and then bind them in the same thread group. So 5 threads are now in the same thread group. So you can interrupt all the threads at once. And this was the purpose of creation of the thread group class. Now, priority. talking about the priority, by default the priority is 5, which is the normal priority. It is not minimum priority, it is not the maximum priority. So priority ranges from anywhere from 1 to 10. It increases in terms of numbers. So 1, 2, 3. It cannot be that it is decimal. 1.1 does not make sense. So it is thread.min priority, value has 1. Thread.max priority has the value 10. And by default, the priority, if you do not set the explicit priority, then it is 5, which is the normal priority. These are, by the way, constants defined in the thread class itself. That's why we are doing thread dot and then the variable name. This is the static variables. A thread of higher priority is executed first. So suppose there is a road and there is a prime minister coming and there is a common man and there is a barricade. What do you think? Who will be allowed first by the policeman? The obvious answer is prime minister, because prime minister has higher priority, has more importance than a common man. So that's why a thread with higher priority will be executed first by the operating system. But you can override the priority anytime using the set priority method. If you do not use this method, like in this program, we did not use set priority method, and hence the priority is by default 5. But if you use set priority method, then you can set it anywhere from 1 to 10, inclusive 1 and 10, and anywhere in the integer range. So we discussed the thread group and the thread priorities. Let's come to the next question, which is, what are the types of threads? So threads are of two types. One is the user thread, one is the daemon thread. Daemon actually means, it is not daemon. Daemon means background. In Linux as well, you will see many processes or commands that can run in background. Similarly, threads can also be daemon. So main thread is a user thread. It runs in the foreground. But daemon threads are low priority threads that run in the background. For example, garbage collector. It runs from time to time. There is no manual intervention needed. And this is a background thread which is auto-spinned by JVM. A daemon thread cannot prevent JVM from shutting. So let's say JVM is trying to shut down. Sometimes you might have seen that if you shut down your Mac, it will wait for some processes to complete. But a daemon thread cannot prevent JVM from shutting. So even if a daemon thread is running, doing its work, JVM can be shut down. Once all user threads are done executing, JVM exits. So what does this mean? Let's say this program itself is running. Once this is done execution, this is the output. The program will end. The JVM will exit, right? It does not wait for the GC, the garbage collector, to run. Although in this case, we did not create explicitly any object, but the JVM does not wait for the GC because it is a daemon thread. Now, coming to the next question, how to create a user thread in Java? We just discussed that threads are of two types. One is the user thread, one is the daemon thread. The question is, how do we create a user thread? The user thread can be created, as we already discussed, using either thread class or using the runnable interface. So let's discuss both the ways. So first is extending a thread class. So thread class internally implements runnable. So even if you use directly runnable or you use thread class, thread internally also uses runnable interface. So how do we create a new thread using thread class extension? We write extends thread after our class name. And then this thread class provides a run method, which we override. So in this run method, we write our logic. In this case, it is a simple logic that it is a loop printing I value from 0, 1, 2, 3, 4. So 0 to 5. 5 is explicit. Then in the main method, we create an object of this class, my thread class. And then I do object dot start. Start is not anywhere here. So what is start? Start is an internal method which basically first provides the resources, because when thread is running, it will need some resources as well. And then it calls, once the resources are allocated, it will call the run method automatically. So there is no need to call thread one.run. This is not needed and is actually wrong. If you want a thread to run, then you have to always call start. Start takes care of responsibility of calling the run method internally. So this will output 0, 1, 2, 3, 4 as we already discussed, since this is just a loop. The second way is implementing the runnable interface. So from Java knowledge, you already know that classes are extended and interfaces are implemented. So runnable is an functional interface. What is a functional interface? Functional interface is an interface that has exactly one abstract method. And this is actually used to create lambda expressions, as we will see later. So it is a functional interface. If you don't know what a functional interface or want to know in depth, then please feel free to comment on the video and I will create one. It is better since it allows extending other classes. You know that multiple inheritance is not allowed in Java because of the diamond problem in C++. And due to that, it is generally recommended to use runnable interface so that if needed, the class can extend other class. So it allows extending other class and hence it is considered better since multiple inheritance is not allowed in Java due to diamond problem in C++. If you don't know or you are not aware of the diamond problem in C++, feel free to comment and I will create a video on that as well. So as usual, we create our class, but after our class name, we write implements runnable because an interface is implemented. Then runnable itself provides a run method which we override and write our logic inside this method. This is again the same logic, so it should print 0, 1, 2, 3, 4. Now in the main method, we cannot directly create an object of interface because we cannot instantiate interfaces. Thus, we first create the object of this class and then we create a new object of thread where we pass this object, thread1. And then I directly call the dot start. You can also write this as thread t is equals to new thread inside which you pass thread1 object. And then you call t dot start. This is the equivalent thing. But since t is not used anywhere apart from dot start, that's why I have omitted t and directly written this and then dot start. So this and then dot start. So this will also output 0, 1, 2, 3, 4 as we already discussed here. Coming to the next question. What is the difference between start and run? And what is the difference between these two and join? So start and run we already discussed, where I told you that start first provides the resources for threads to run and then internally calls run. Calling run directly is actually wrong from threading perspective. It will run like a normal method. So start creates a new thread and schedules it for execution. It automatically invokes the run method. It can only be called once per thread. So you cannot do thread.start and then again call thread.start. This will actually give you illegal thread state exception. Since thread is already started, when I called the start method first time, this thread started executing. Now if I call it again, then it will say that this thread is already executing. So this is illegal thread state exception. The thread is not in a state that can be run, it is already running. Run on the other hand does not create a new thread, as I already told you. And if called directly, it is executed just like a normal method. Join makes main thread to wait for the thread on which it is called. So if I call t.join in the main method, that means main method won't exit. It will halt at this, it will be blocked at this line and it will wait for the t to complete. So basically join makes the main thread to wait or be blocked for the thread on which it is called. So it will wait for the t's completion. And after that it will further proceed and will exit. So for example, thread1.join 2000. Now generally in the arguments we pass in milliseconds. So this is actually 2000 milliseconds, which is equal to 2 seconds. So then main thread will wait for 2 seconds or the end of thread 1 before proceeding further, whichever is earlier. So let's say thread 1 completed in 1 second only. Then main won't wait for 2 seconds. It will proceed. But let's say thread 1 took 3 seconds. But since we only requested for 2 seconds, after 2 seconds it will proceed. So whichever is minimum, either 2 seconds or the completion time of thread 1, main will wait till those time, the minimum of these two. But if I do not pass any explicit type, can just write dot join, then main thread will wait for the end of thread 1 before proceeding further. So even if thread 1 is actually blocked, then main thread is also blocked. It won't proceed further. Now, why outputs contain mix of outputs of individual threads? You might have noticed that you in some of the programs involving threads, you cannot reliably tell the output. Why is that so? Think a bit on this. The answer is due to context switch. Which thread will be executed is decided by ThreadPoolExecutor which is the part of JVM and is vendor dependent. That means there are a lot of vendors, which we call as JVM vendors. So JVM specification is there online, and then based on that specification, each vendor generates its own JVM. For example, Oracle is there, then Azure is there, Microsoft is there, and I think Eclipse is also there. And some of the JVMs they provide is this is Oracle JDK they provide. Azure provides Zulu, which is largely used in enterprise systems. Then similarly, Microsoft provides, Eclipse provides, and a lot of other vendors are there. So the specification, if somewhere it is not mentioned clearly, then each vendor implements its own logic, and hence the thread pool executor, which is whose responsibility is to decide which thread will be executed, is now vendor dependent. And hence we cannot reliably predict what will be the permutation and combination of output. It depends on the JVM vendor, the JVM which you are using. We can only tell the possible outputs. Yes, if there are, let's say, 3 possible outputs, for example, two threads are printing 0 to 3, then any permutation combination of these we can generate and say that the output will be one of these possible values. But which one will come is again vendor dependent. And that's why the outputs generally contain a mix of outputs when anything is involved in threads. Now, we discussed in one of the questions that how do we create a user thread? We discussed that there are two ways. One is using extension of the thread class. One is implementation of the runnable interface. But how do we create a Daemon thread, which is another type of thread? So this is created using a method called as setDaemon. So we create a class in the similar way we created above. Just that once the thread object is created, we set the daemon to true. By default, it is false. So it is a user thread. But once I call set daemon true on this object, this thread object, then this thread object, whenever starts executing, it will be executed as a daemon thread. This set daemon can only be called before the execution starts. So I called start here. I have to call the set daemon before this. If I do not do that, again illegal thread state exception will be thrown. So first I set daemon to true, then I start the thread. And if you want to know if your thread is a daemon or not, you can just use isDaemon method, which will print. So since I called set daemon to true, it will print true. So it printed true. Then I started it. So start is having the same logic, so it will print 0 to 4. 0, 1, 2, 3, 4. The next question is, what are the different states of a thread? When we saw this exception that this is illegal thread state, that means there are some states, possible states. The question asked is, what are the possible states? So we have to explain the thread lifecycle as well. So basically there are 5 possible states. One is new. When the object of thread exists, but start is not yet called. So if you go to this line, once this is executed, we are on this line, then this object exists, but it is not yet started because start will be called later. So this is the new state. The object exists, but start is not called yet. Then it becomes runnable. That means it is able to run. So it is runable. That means thread is ready, but it does not have the resources as of now. So it is able to run, but due to the lack of resources, it is not able to run. Then running. Once the resources are obtained, like CPU and memory necessary for the thread's execution, it starts running and its state is running. Then there is another state called waiting. For example, this thread is waiting for you to input some data, or it is waiting for download of a file. This state is known as waiting. It is blocked on something. So it is blocked on some input output IO, for example, download of a file or other thread. Other thread might also block its execution. And once it is done or some error is encountered, it is in the terminated or the dead state. So yield method is like, there is a yield method. For example, if I draw this, then it is new, then it is runnable, then it is running. There are two more states. One is waiting and one is dead. So from new I go to runnable, from runnable I go to running. Once the thread is running, it can go again to runnable by calling the yield method. From running, it can go to dead, it can go to waiting. If it goes to waiting, then it again has to go from runnable. So this is the finite state machine or the finite state automaton for the states. And this can be represented using state design pattern. So if you are not aware about this, then please feel free to know or let me know in the comment section, and I will try to create a video on state design pattern. So what is yield method? We discussed that it is used to move a thread from running to runnable state. So it is like, I had enough time in the limelight, can some other thread run instead? But if no other thread has higher priority, we discussed what a thread priority is, then the scheduler will again run it. From inter-thread communication, we have methods from object class itself. So object class provides many methods. For example, toString, hashcode, equals. Similarly, it provides wait, notify, and notify all methods as well. And these three methods are used for inter-thread communication. So for example, wait, we call it as thread1.wait. Notify, it notifies the waiting thread. Notify all, used when more than one threads might be waiting on current thread. We will discuss these in more details, but as of now, just consider that object class itself provides three methods which are used for inter-thread communication. The next question is, what is executor service? Executor service is a class which is a modern way to deal with threads in Java. This is in the java.util.concurrent package. So this is the package you need. It is very similar to ThreadPool and is a new way to execute tasks in asynchronously. So we import this class and we also import executors class from the java.util.concurrent package. Then we create thread object in the same way we created before. So extending thread, then writing our logic for looping. And in the main class, I created the object of the thread class, and then I used the executor service. Earlier we were doing new thread. If you look at the above code, you will see that I was doing a new thread. This is the manual way. But I can reuse the threads again. And this reuse is supported by executor service. So I will write like this: executor service equals executors dot new single thread executor. Then I will write this object dot execute, and then I will pass this thread. So this will automatically call the start, then start will call run, and this will execute this logic. And once I call shutdown on this object, then it won't accept any more task. So this will output 0, 1, 2, 3, 4, as we already discussed, because the logic is the same. The only thing changing is how do we call this run method. So here we use new single thread executor. So only one thread is there in the code. Then we call the execute, which will call start, and then we'll call run. And then we call shutdown so that it cannot accept any more task. We can also create different types of services. For example, above we created single thread executor. Here we can create, let's say for 10 threads we want to create, and these 10 threads will be reused. So we write like this: executors dot new fixed thread pool. Then I pass the number. So this pool will be having 10 threads. This is the pool. This is the thread pool. So maximum number of threads which can be reused. For example, executor service, then object name is equals to executors dot new fixed thread pool, and then I pass the number, how many threads I want in this pool. We can also check if service has executed successfully by using the future class. For example, executor service, then object is equals to executors dot new single thread executor, as usual before. Then when I do executor service dot execute, I was writing. But if I do this, execute is a void method. It does not return anything. If I want to know the status of this thread, then I want to do a submit. So when I do a submit, then it returns a future. And this future I can call get to know if this thread is completed or not. Remember that this get is a blocking call. So until this thread now completes, main method will be blocked. Then the next question is runnable versus callable. So callable is comparatively a new way and is a nice alternative to runnable. So earlier the only way for threads to return a value was to store it somewhere, because you know that the run method is a void, so it cannot return anything. So for a thread to return any value, it has to persist somewhere. For example, in a file, the threads used to write, then another thread used to read from those files. Since runnable has void return type, for example, runnable's run method is having void return type, so it cannot return anything. But with callable, which is also a functional interface, we can make a thread to return a value. How? For example, I created this as in our usual logic. So this is our usual logic. But when creation of the executor service object, when I do a submit, I passed a lambda method. And this returns a future, as we already discussed in the above example. When I do future.get, if it returns null, that means no exception was thrown and the thread has completed successfully. This lambda is nothing. This lambda expression is nothing but equivalent of writing this new callable. Then I override call method. Runnable has run method. So if I write runnable, then it has a run method. But callable interface has a call method. And it returns an object. So anything you can return. It is not bounded by that you have to return string or you have to return an array or a list. Anything you can return, since this is an object which is the superclass of every class. So I return Gaurav Kabra from here. This is equivalent of writing this lambda expression. The next question is, what is synchronization of threads and why is it needed? Synchronization is used to execute code in sync way, that is one at a time in an orderly fashion. It does not mean that we have to execute one by one. It means that in a definite order we want to execute. We want a control over the order of execution, not simultaneously by threads. So basically control on the order of execution. This avoids race condition, which occurs when multiple threads access modify shared data simultaneously, the critical section, leading to unpredictable and incorrect results. How? Look at this example. I created a very simple class counter which has a object count which is set to 0 initially. There is a method increment, whenever it is called, it increments the count by 1. And then there is a getter to get the count. So this is the getter. Now in the main class, in the main method, I created an object of this counter class. Then I spinned off 2 threads, thread 1 and thread 2. So each thread basically tries to increment the counter by 1000. Because each time it calls increment, this count is incremented by 1. So if I have to increase the count by 1000, that means I have to call increment method 1000 times. Similarly, thread 2 also tries to increment it by 1000. Then I start the threads, and then in the main I write that wait for T1 and T2 to complete using the join method that we already discussed. Now, without synchronization, do you see anywhere I have written any synchronization logic? The answer is no. So without synchronization, the chances are high that the result will always be less than 2000. See, ideally, if thread 1 is incrementing by 1000, thread 2 is incrementing count by 1000. That means the total increment is by 2000. But this is not the case because we are not doing a synchronization. So the final count, in my case, it was 1960. That means it was lagging by 40. To get the correct count of 2000, we want that only one thread where we are doing the manipulation of count. We are doing the manipulation in this method. And let's say thread 1 and thread 2. This was the state. Count was, let's say, 1. So thread 1 read 1, thread 2 also read 1 due to context switch. Then thread 1 incremented it by 1, so it is 2, and then committed. So now when written, this is in the register, it is 2. But thread 2 also had read the value as 1. Although now it is 2, but the old state is 1. It will increment and write it again. So though we incremented, we should have incremented it by 2. 1 by thread 1, 1 by thread 2. But it is only incremented by 1. And hence, that's why we see that this number is less than what was intended. So we just write a synchronized void. So this synchronized keyword when added at the method level. So it is the method synchronization, and hence now only one thread will be able to modify the count at a time. Basically only one thread will be able to enter the method at a given moment of time. Now the next question is synchronized method, which we already discussed here, versus synchronized block, which to use when. So there are two concepts. One is the synchronized method, which we already discussed in the above example. Another is the synchronized block. So one disadvantage of synchronization is that it slows down the application. We are gaining the control over the order, but at the same time, it is slowing down the application. If inside a method, we only want a few lines to be synchronized. Let's say there was a method, let's say foo. And here I have many lines of code. Let's say this, but I only want a middle few lines to be synchronized. This is the critical section for me. Then why do I need to make this whole method as synchronized? Does it make sense? The answer is no. So if inside a method we only want a few lines to be synchronized, then instead of synchronizing whole method, we just put that part in a code block which is called as synchronized block. So I will just put this critical section lines in the synchronized block. How I will do that is, I will write synchronized, then on this object. So lock is on this object, and then I will write the critical section code here. The above lines and below lines, which are not a critical section, I don't care about those lines. So now you see that fun is not a synchronized method, but it has a synchronized block. We cannot use synchronized with constructors, variables, and static and instance initializers. But constructors can have synchronized blocks. So when to use synchronized blocks? The first idea is if you want only few lines to be synchronized, then use the synchronized block. Second is constructors, variables, static and instance initializers cannot be synchronized at a method level. Then also use synchronized blocks. So which to use when? Blocks are better in general because synchronize only relevant part of code. This will improve the performance. Come to the next question, which is, can we have synchronized static methods? For example, in the above example, the increment is an instance method. It is not static, right? So it is concerned with an object. You can only call it on an object. So how do we synchronize it? We either write synchronized or we put a synchronized this, right? But can we synchronize static methods as well? The answer is yes. We can synchronize it on the class level. For example, I can write like this: synchronized, then the class name. For example, main dot class, and then I can write the critical section code. So that's how you can synchronize the static methods as well. So that's all for this video. I hope you liked the video. You are gaining some insight by going through the interview questions which are asked very frequently. In the next videos or one of the upcoming videos, I will try to cover the rest of the questions as well. If you like the video, please consider sharing and subscribing to the channel. If you have any suggestions or any topics which you are finding hard to understand, please write so in the comment section and I will try to cover those topics in one of the upcoming videos. Thank you so much.